Okay. Hey, girly. So, sorry, I was on the floor because I just wanted to make sure that when I eventually share this with you, that you'll be able to see it correctly. So I apologize about that in advance. But yes, so all right, so right now we're going to be talking about variables and expressions. So just to start, we're starting real basic so that way, because I feel like some, sorry that you can't really see me like that, but I feel like there's pieces that you don't know and there's pieces that you do know. So I'm kind of starting from the beginning from you. Good thing is that you're not like too far along, so that way like I can really get you to understand everything that you need to learn in algebra, especially going forward. So let's start. So talking about variables and expressions. So we first have to go through a little bit of vocab because I'm going to be saying some things and I want to be sure that you can understand what I'm saying. So vocab. So the first word that we have is variable. I hope that you'll be able to see this, whatever. Okay, so a variable is a letter, so like X, A, B, C, whatever. A letter or symbol used to represent a value that can change. I apologize about the going back and forth. So yes, a variable is a letter or a symbol used to represent a value that can change. I'm going to have you, have that up. So there's that. Now, we're going to think of some examples, of them. So what do you think? So some examples could be X. That's usually a very common one. But they can also be Y. It could also be Z. It could also be, symbols that look like this. It can be symbols, that sort of stuff. Next. So next vocab word is a constant. Right? A constant is a value that does not change. It's very important is the fact that it does not change. Okay? So an example of a constant would be like 12. Because 12 isn't changing. 12 is 12 is 12. It doesn't matter. You could even say 1,000. That's a constant. That is not going to change. So yes. Next up, we have a numerical expression. So I have to get on my knees. Numerical expression. And that may contain constants and or operations. And operations is, operations is just like the general term for addition, subtraction, multiplication, and division. Okay, I didn't feel like writing that out, but you understand. So numerical expression may contain constants and or operations. Now we have algebraic expressions. And those may contain variables constants, and slash or operations. Okay, so we know what variables are, you know, because we said that a variable is a letter or a symbol that is used to represent a value that can change. So these algebraic expressions can have that. They can also have constants, values that do not change, and they can also have operations, which we said was like a fancy word to sum up basically addition, subtraction, multiplication, division. Numerical expressions can only contain constants and or operations. So the big difference between numerical expressions and algebraic is that numerical is really just numbers and like, you know, addition and subtraction. Whereas algebraic, that just means that you're going to have variables or letters slash symbols. Okay. So I hope that, you know, makes sense. So yeah. So one thing that I also, oh, sorry, my bad. Okay, so basically moving on. Sorry about that. I will, you know what, I'll actually pause these while I'm erasing. Okay, done erasing. So the next thing that I want to learn is how to all right, so next we're going to learn how to translate from algebraic symbols to words and stuff. So basically, I'm going to break this up. I think I have a red. Good. All right. So when we're talking about addition, right, we might say plus, right? So we might say like 3 plus 9. We might also say the sum. So what is the sum of 3 and 9, which means basically 3 plus 9? Or we might say increased by, which just means like what is 3 increased by 9? You know, you can say that. Next up, we have subtraction, which is used but this time. And this just, you can say minus, so you can say, ooh, so sorry. So you can say 5 minus 3. You could also use the word difference. So you might hear, you know, like what is the difference of 5 and 3? Or you might hear less than. You might say, what is 5 or what is 3 less than 5? Next up, we have multiplication, which is usually shown with an X. I don't think you can see that. So for all intents and purposes, we're gonna try brown and we'll see if my brown works. It's not too bad. Okay, so you might use times, some words. So like 3 times 6. Or you might hear the word product. So what is the product of 3 and 6? You might also hear equal groups of. But that's not as common. And last but not least, I think this is purple. No, I think this is purple. That's black. Sorry, I'm colorblind. Divided by. That is a division symbol. Apologize about. There you go. Now you can definitely tell. So this is a lot simpler. Divided by use, and then sometimes you'll see quotient. What is the quotient? Or find the quotient of blah blah. Okay. So those are really important in terms of writing words into expressions. Algebraic expressions into words. So we want to find 2 ways to write each algebraic expression in words. So to start with, we're going to do can't see that. You can kind of see that. All right, we're going to do x plus 3. So one way you can say that is x okay, so we're going to try and like fill in these blanks. There's 2 ways that you can say that. It's really 3 because there's 3 up here, but we don't really use one of them like that. So yeah. So you have x plus 3. Well, that's just by reading it, that tells you the first one, x plus 3. Now for this one, do you want to try it? So the blank of x and 3. The blank of x and 3. So it's the sum. The sum of x and 3. So now we're going to do another one. We have m minus 7. Right? So we can say the blank of m and 7. We can say m blank 7. We can also say 7 blank m. Okay? So I think the middle one is the easiest because it's basically said how, like read how it's said. So this is m minus 7. And that's normal. That's how we'd read that. So that one's minus. Now, do you want to take a guess for these 2? So let's start with the first one. So it's the blank of m and 7. I'll give you a hint. It's definitely up there. So the blank of what? Of m and 7. We also have 7 blank m. So we already used minus. So there's only 2 more we can use. So take a guess of what this one is. The blank of m and 7. Okay, so it's the difference. The difference of m and 7, which means the last one now has to be what? The last one has to be 7 less than m. Okay? Now we're going to do 2 more. Let me just erase this real quick. Okay, so 2 more. So that is a multiplication symbol. Sometimes you'll see it written as a dot as well. I'll put that here. There's many different ways that it's usually written. So for this one, we're just going to use 2. So 2 examples. So we have 2 blank y, and we'll use the blank of 2 and y. So this is another one where it's kind of said how it's read or whatever. So in this case, this is, when you read it, 2 times y, or 2 multiplied by whatever. So in this case, this first one is times. So now, 2 times y. So for our second one, I want you to think. So it's the blank of 2 and y. We already used times. Okay, so it can't be that one. And if you remember, I said that there was one that is used more out of these two, and you've probably seen it more before. So try and guess. Is it the product of 2 and y? Or would you say the equal group of 2 and y? I mean, I guess they're both kind of right, but which one am I looking for here? Okay, so I am looking for a product. So the product of 2 and y. All right. And our last one. Oops, I kind of gave you an answer there. Sorry. All right, so same thing. You have number 4, which is how it said, k divided by 3, and I kind of already gave you the answer. So divided by, and then the blank of k and 3. There's only 2 words here, so we have to use quotient. Sorry about my spelling, but if you really want to, it's right there. It's quotient. All right, so that's that. Okay, so now that we understand what each of them means, now we want to now translate the words to algebraic symbols. So we're like literally just gonna switch our title around. So from words to algebraic symbols. So, sorry. Okay. So, number 1. Okay. So we have, I'll pause it while I write this out. Okay. So number 1, Eve reads 25 pages per hour. Write an expression for the number of pages she reads in H hours. So my big thing is to always underline, circle, whatever you have to do, highlight the important information. So she's reading. All right, cool. What is she reading? She's reading 25 pages per hour. That is mucho importante. Okay, that's very big. Write an expression for the number of pages. Okay, so that's what we're trying to figure out. She reads in H hours. This is also important, especially because this has our what? Our variable. This H right here is, the problem is telling us that we need to write hours as an H. That's going to be our variable. So that's basically what it has in here. H represents the number of hours she reads. I abbreviate all the time. I'm so sorry. That is hours. Okay. So H represents the number of hours she reads. So think H groups of 25 pages. That's how we're thinking. So if we had to write an expression, what do you think that we would write it as? Okay. Welcome back. So you can write it as 25H, or I'm sorry, 25 times H, or you can write it as 25H. And here's why. Basically, they want to know how many pages per hour. So you could just say, let's say like she read for 2 hours. So if she read for 2 hours, you could sit there and go, okay, well, 25 plus 25 equals 50. You could do that. And, you're good. But what if I said that she read 70 hours? I'm sorry, 7 hours. You don't want to do 25 plus 25 plus 25. You don't want to do all that. So it's easier to write the expression in terms of multiplication. So that way, it's easier for any value that you plug into H. Because like we said, with variables can represent any number. So you have 25H, or 25 times H, same thing. So that way, if then the problem goes on to say, well, if she read, how many hours did she read for 4 times? I can just, or I'm sorry, if she read for 4 hours, how many pages? You could just say 25 times 4 equals 100. You know, and like that would be your answer. In this case, they just wanted us to write the expression. So this is the expression. Technically, it's an algebraic expression because it has a constant, an operation, which is a multiplication, and it has a variable. Okay, so moving on. Okay, so we're back on to number 2, and I wrote out number 3 as well, but we're just focusing on what's red for right now up here. So Sam is 2 years younger than Sue, who is Y years old. Write an expression for Sam's age. Once again, important details. So we're talking about Sam's age. That's like the subject. So Sam is 2 years younger than Sue. Okay, so Sam, that's important. We need to know who we're talking about. Is 2 years younger than Sue. Sorry. And Sue is Y years old. And once again, this is telling you what your variable is going to be and what your variable stands for, you know, what it represents. Write the expression for Sam's age. So, same thing. Sam is 2 years younger than Sue. So, you know, we'll do Sam is X, and we'll make sure that Sue is Z, and obviously his age is Y, or something like that. So we want to have Sam, so we have Sam. And we have Sue, who's 2 years older than him. So, really, we need to focus on Sue. So, Sue, which is our Z, is 2 years older than him. I'm sorry, yeah. Yeah, she's 2 years older than him. So, minus 2 is equal to Sam. So Sue's age minus 2 is equal to his age. So in this case, we would do Y minus 2. Because in this case, they said that Sue is Y years old. So she's actually Y. I'm sorry about that. I didn't mean to confuse you. So Sue and her age is actually Y. So you do Y minus 2 because Y minus 2, if let's say if they said that she was 7, so if they said, oh yeah, Sue is 7 now. So how old is Sam? Well, then you would just do 7 minus 2 and you'd find out that Sam would equal 5. Okay, that's just an example, but the actual expression that we need is right here, which is Y minus 2. Moving on. We have number 3, right here in the blue. I'll leave time for questions too. Right here in the blue. William runs a mile in 12 minutes. Write an expression for the number of miles that William runs in M minutes. So, you know what we got to do? Mark it up. He runs 1 mile in 12 minutes. Very important. Write an expression for the number of miles. So you want to know the number of miles that he runs in M minutes. This is very similar to the first one that we did with Eve reading the 25 pages. So I want you to use that and try and figure it out. Do that now. Okay, so the answer in this case would be 12. Number of miles he could Sorry. Oh, I didn't pause. Oh, I don't have to. Sorry. So the answer in this case would be 12M. Why? Because he runs that mile in 12 minutes, and they want to know the number of miles he can run in M minutes. So if he does 1 mile per 12 minutes, so let's say if we did like, you know, I don't know, like, oh, sorry, 1 second. I am so sorry. I gave you the wrong answer. I'm so sorry. I read the wrong thing. All right. So the answer is not like the other one. I apologize about that. It's M divided by 12. And why? Because it takes how many groups are in, how many of 12 are in M? All right. So they want to know the number of minutes. So if he runs 6 minutes, you know that he is essentially doing half of a mile. I hope that makes sense. So that is why our expression is M over 12, because they want to know how many minutes. Like basically, M represents minutes. So if we know that he does in 1 whole minute, it's a mile. 6 minutes is a half a mile. So whatever your equal sign is going to be, if you try to figure it out, will be the distance that he ran. Okay. There's that. Let me know if you have any questions. Okay, moving on. So I wrote this all out. So now we're going to be talking about evaluating algebraic expressions. So we already know from our vocab before what algebraic expressions are. Remember, they have a constant, they have an operation, and they have a variable. But now, like, what's evaluating? So here we have a little vocab moment. So evaluate, or to evaluate, means to find the value of. You'll understand what I'm saying in a minute. So, for example, it says, evaluate each expression for x equals 8, y equals 5, and z equals 4. And they give you some expressions. So number 1 is x plus y. So remember, we're evaluating, which means we're finding the value for. And I say this a lot. Basically, this just means that we are plugging in. And when I say that, I literally just mean that. So they already told us what these values are. They said x is equal to 8. So I'm going to plug that in here. Okay. Then they said, you know what I'll do? I'll color code. Okay, that's X. Right? Then they said, I don't have any like crazy different colors, so I apologize about that. Then they said that y is equal to 5. So there's that, and it wants you to find the value, so which means they want to figure out what it equals, and 8 plus 5 equals 13. So in this case, x plus y is the same thing as saying 8 plus 5, because x equals 8 and y equals 5, and then that gives you 13. Moving on to our next example. We have x over z. Same thing, right? So we're plugging in. So yes, we're plugging in. So we set our x equals 8. So x is going to equal 8 here as well. But now we have z. So now we have to figure out, well, it says in our problem that z equals 4. So there's that. And they want you to evaluate it. 8 divided by 4 equals 2. So that's your answer. X divided by z, or 8 divided by 4 equals 2, because that's what the problem said. I hope you paid attention to the last one. the last little thing that I gave you on this Ed puzzle because that's going to help you for this one. So, remember, I'll reread the problem just in case, but approximately 14 20-ounce bottles must be recycled to produce 1 square foot of carpet. So, A says to write an expression. All right, now I'm writing down my key information just because I'm not writing the whole problem. Write an expression for the number of bottles needed to make C square feet of carpet. So in this case, we know this is going to be our variable, this little C right here. And it says it takes, and just some other key information, it takes 14 bottles to make 1 square feet of carpet, okay? So the expression, take a guess as to what it is. Okay, the expression is 14C because 14 makes 1. So let's say they wanted to know how many, let's say they said, okay, boss, your boss says, I need you to make 5, I'm sorry. Okay, we'll do 3. I need you to make 3 square feet of carpet. Well, how many bottles are you going to need to do that? Well, you're going to multiply it. So if you wanted 3, you would have to do, this is just an example. This is what they wanted you to write, but this is just an example. You would do 14 times 3 because the carpet, the C is the square feet of the carpet. So they want you to make 3, and then you would get, what is that? That's like 7 times 6. 7 times 35, 42, I believe. Then they would need 42 bottles. So that's how you would kind of figure that out. So now moving on to letra B. All right, so you should have read that thing. So now B says to find the number of bottles needed to make 40, 120, and 224 square feet of carpet. So we said from our expression, I really hope you can see that it's 14C. I'm going to write it over again, but that's your expression that we're supposed to be using. So, easiest way is to make a chart, right? I love me a good chart. Okay? So, C is the amount of carpet we need. So they want to know how many bottles we need for 40 square feet of carpet. So 40 square feet, right? They need 120. And they need 224. I'm sorry. Yeah, 224, my bad. I wrote 244. So 14C was our expression. So we're going to plug in our C. So we have 14 times 40, and that gives me 560. We have 14, plugging in our C, 120, and that gives us 1,680. Then we have 224, so we have 14 times 224, just plugging it in again, and we get 3,136. And these are all bottles. So, according to this problem, to make 42 square feet of carpet, we need 560 bottles. To make 120, we need 1,680. To make 224 feet, we need 3,136. Questions? Okay, so we are done. The end. What questions do you have? You can either text me or I will provide space in this and the Quizlet for you to have questions as well. But that's basically the end of our first little mini lesson, and I'm going to post this on your Google Classroom. Okay, bye.